Okay, guys, let's do part four. Still more trig. So remember, sine, cosine, tangent. Make sure we're picking those right reference angles and aligning the sides correctly. So in the previous trig that we did, some pretty just kind of straightforward, what we call naked problems sometimes. Now here, looks like we're going to dig a little deeper into some conceptual stuff. So here you go. So find the value of h1, assuming that h2 is equal to 56 meters. Now, here you have to be really careful on the labeling. So it says h2 is 56 meters, so they just mean this stretch right here is 56 meters, at least I'm assuming so. And we need to find the value of h1. I'm just going to call it x. So we have to be careful here because there's a temptation to use sine, cosine, and tangent, say with this triangle, because you see the 60 degrees labeled, you see the 56 labeled, but in truth you can't because it's not a right triangle. Sine, cosine, and tangent only work with right triangles, so that is not going to be our pathway. Instead, what we're going to do is kind of make a observation that we have the bottom, which is 300 meters, and in truth we also have this side. We don't have the whole value of this side, but if the top portion is 56 and the bottom portion is x, we can actually call this entire side 56 plus x. And use that just like you would any other side length. If you look over at the angle, we have part of it 60, part of it 25, which means the entire angle is 85 degrees. And so instead of looking at this as like two small triangles, we're going to actually look at it as one big triangle. And then we'll do some algebraic work on the back end to find for x. Anyway, let's go ahead and set some equations up to solve. So we have 85, we have this long side, this 56 plus x part, and we have the bottom part, which has 300 meters. So we have the opposite, we have the adjacent. That tells me we're using tangent. So let's start out with this. We have the tangent of 85 is equal to opposite, which is 56 plus x, over adjacent, which is just 300 meters. So right now it's not super apparent maybe what we're going to be doing, but what we can do, if we don't have any ideas, we can just start doing some algebra to get x by itself, because ultimately what we really want is that x. So let's get that x by itself. Let's turn into this a basic algebra problem. So let's do some cross multiply. So we cross multiply this way, we'll get this 56 plus x. If we cross multiply the other way, we'll get equals to 300 times tangent of 85. We're getting close because we're close to having x by itself, but it's not all the way there. So let's go ahead and subtract 56 from this side and subtract 56 from this side. So we're getting to some fairly complicated looking algebra, but remember these are just numbers and they behave that way. And so we have this 300 times tangent of 85. Now subtract 56 from it. So let me grab my calculator, because it looks like we can maybe just go ahead and solve outright here. Okay. So let's see, 300 times tangent of 85. Again, make sure your calculators are in degree mode. And we'll take that result and then we'll subtract 56 from it. And so I got my x to be approximately 3,373.02, and this will be meters. Okay, so going back to our problem, that means this little bit right here, the x value by itself is 3373.02. Okay. Now I know you're saying, well, man, that seems like a pretty big number. It should make some sense, because if the if you consider like this angle here is 85, we kind of expect this value to be quite large. So although it's a large number, it's not a outrageously large number. So we should be okay. All right, so let's move on. All right, so this is a find the value of angle x and angle y. So we're going to be using some inverse trig here. It doesn't really matter which one you do first. Let's just solve for y. And so if we go back to kind of our standard thought process, if we're sitting at y, 48 would be the opposite side, 62 would be the adjacent. And since we're trying to find the angle, we need to call up the inverse function. And so it's definitely going to be tangent because we have opposite and adjacent. But we are going to use the inverse version of that. Feed it the tangent function ratio, opposite over adjacent, in this case 48 over 62. And then we can just calculate what theta would be. I guess let's call it by the real thing, what y would be. Okay, so go to the calculator. We feed the tangent inverse function 48 divided by 62. We get the tangent of, or, I'm sorry, the angle value to be approximately 37.75. And so 37.75 degrees. So we can do a similar thing for x. Now, since we're switching it to x, we're going to be now switching what adjacent and hypotenuse are, opposite are. So 62 becomes the opposite, 48 is the adjacent. And so we're going to be dealing again with a tangent function, or an inverse tangent function. But now we're going to feed it 62 over 48. Okay. And so we get 52.25. Well, approximately 52.25. Now, this is a really easy check to see if you got it right. X and y together have to add up to all the remaining angles of the triangle, in this case 90. So if you take 52.25 at 37.25 for it, you'll find that does indeed equal 90 degrees. So it looks like we're good there. Let's see, find the values of x and y. And x and y are sides. And so it looks like we're going to be doing some, using some straight up trig. Let's solve for x first. So we need to pick a reference angle for x, and then maybe use some side lengths. I'm going to use 68 for my reference angle, and so if I'm sitting at 68, this guy would be my opposite side, and then I'll go ahead and use my hypotenuse side. So if I'm dealing with opposite over hypotenuse, that's going to be sine. So this reference angle is the same as opposite over hypotenuse, in this case x over 450. So when I'm solving for x, I can simply multiply 450 to both sides. Okay, and that'll allow me to get a nice approximate value for x. The approximate value of x I got is 417.23. And that makes sense because, well, 68 is larger than 22, so you expect x to be pretty big, but not quite as big as 450, and it falls right into line. Now we need to find for y. I'm going to use 22 this time, so I'm going to set up another sine function because 22 is y, that's opposite 22, and I can reuse hypotenuse. So the sine using 22 as a reference angle is the same as the opposite, which is y, divided by 450, which is the hypotenuse. Just like before, we're going to multiply both sides by 450. Which should give me a nice approximate value for y. Of about 168.57. Okay. It says angle x, angle y here. I'm going to presume they actually mean like values of the side length. So let's change that. Let's cross out the angle part. So x is 417.23, and y is 168.57. And again, uh, y is across from 22 degrees, which is the smallest angle. We expect that side to be small. Now there is a quick way we can check this since we're at the end. We can go ahead and do it again. Don't forget, like since you're dealing with right triangles, Pythagorean theorem is always going to be in play. And so if we're wondering if this is correct or not, we can always feed it right into the Pythagorean theorem and see if it actually does match. So we can tell if we got the right values or not. So x squared plus y squared in this case should be equal to 450 squared. So we can take these values that we got. So if we take 417.23 squared plus 168.57 squared, that should equal about to 450 squared. Not perfect, and again, this is just extra check work, but it's no reason not to do it. There's no reason to turn in the wrong answer, so let's go ahead and check it. Okay, so we have 417.23 squared plus 168.57 squared. So we get some ludicrously large number. Let's go ahead and square root this bad boy. And I got 449.99, which everything was rounded, so it's going to check out. So my point on this last part about the Pythagorean theorem, just don't forget that it's in play. I mean, if you can do all this trig, you can find these values, but if you're able to use Pythagorean theorem, it's at least an option, all right? So let's see, that was part 4, because it's page 4. I'll see y'all in part 5, you guys.